All right, page 294 in your textbooks. You did 2 through 12, the even, just some review of basics with matrices, and then what we began working on yesterday with the Gaussian elimination, solving systems of equations using matrices. We had just one of those, and that was number 8, back on page 292. That's 2 through 12, and number 8. 2 through 12, and 8. All right, let's take a look. Starting on page 294, number 2, just adding matrices. Remember, they have to be the same size to add them. Maddie, what did you get?
1, 2, 5, 6, -2.
Good. 1, 2, 5, 6, -2, 1. Number 4, what did you get when you subtracted or added the inverse? Kendall?
-2, -2, 9, 1, -5, 11.
Good. -2, -2, 9, 1, -5, 11 is correct. Number 6, just distributing the scalar. Brandon?
-12, 30, -36, 0, 24, -42, 48, -18, 6.
It's April Fool's Day, and I'm highly suspicious right now.
When we restart the video, we started this off wrong. We need to restart.
Yeah.
Yeah.
Just restart it, okay?
Nope, we're already into
guys,
it.
reset from here.
Start right
exactly.
now.
Reset from here.
Exactly.
Yeah.
I was so confused.
Okay.
Reset from here.
I was like,
It's okay, we can do this.
Yeah. Number 8. We had to, this one comes out a little weird because we don't have all integers. We had to just...
Can we go upstairs and bang back?
Yes.
It should be like drumline, you know?
But we have to do it on the ceiling for us for them to hear us.
Yeah, it's true. Anyway. Seriously, move the ceiling tile, get a broom or something. Bam, 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 bam.
Use the camera.
No, I'm not using the camera. Number 8. Distribute the 4, and then also distributing the half, which means we're not going to keep an integer value here, Genesis.
8.
What do we get on number 8?
8, 0, -12, 4, -4, 1, 3, 3.5. I mean, yeah, 3 over 2. 8, oh, equals 4, 1, -9, 5.5.
Okay, there we go. Or 11 halves if we're lazy, right? So 4, 1, -9, 11 halves is correct. Number 10. Can we multiply those two matrices in the order given? Audrey?
Yes.
All right. I knew it. I knew when I called on her it was going to be you. So I'm like, I got you. But the answer is actually no. Audrey, what are the dimensions of the first matrix?
Audrey?
3 by 2.
And then the next one's also
3 by 2.
so the inner dimensions don't match. So no, we can't multiply in the order stated. Number 12, can we multiply those in the order stated? Michael?
-2, -3, -1, 0. Wait, yes?
The answer is yes. Very good. The answer is yes, we can, because we have a 2 by 3 and or 3 by 2 and a 2 by 3. The inner dimensions match. And it did ask you to solve. I was just asking if you could. And now the next question to follow up is, what do we get for our answer when we do multiply? Whoever I called you the last time.
Okay.
Because you seem like you were on a roll.
Yeah. -2, -3, -3, -1, 0, -1, 3, 9, 4.
Oh, so close, Maddie. What should she have gotten?
-2, -3, -2, 0, -1, 3, 9, 4.
Oh, still no. Something weird with that element 3, 2 happening here. Kendall, can you help her?
-2, -3, -3, -1, 0, -1, 3, 3, 4.
There we go. Good job, Kendall. -2, -3, -3, -1, 0, -1, 3, 3, 4. Way to help out Maddie and Michael on that one. All right. Questions on Gavin? I don't know if you can hear the voices or not. Hopefully you figured out, but one person, I call one person, different person answers. So anyway, all right. Questions on the 2 through 12 even. That was really clever. I like that. Nice. Questions? All right, turn back to page 292. Page 292, and let's take a look at number 8. Now, I will say, as I was kind of working over some of the problems in preparation for today, obviously I wasn't explaining anything, and frankly, I wasn't drawing the matrices super neatly. I was just going fast. It is really fast once you get the hang of it. I'd forgotten just how fast you can solve a system of equations when you just kind of go at your own speed playing with the numbers. But we'll do number 8 at explanation speed, but I will give you opportunities here in just a little bit to kind of solve at your own speed. First of all, we needed to turn number 8, the system of equations, into an augmented matrix. And what is that augmented matrix, Brandon?
1, 1, 1, 1, 1, 1, -2, -2, 3, -2, 1, 6.
Very good. And once we've got our augmented matrix set up, remember the key is to get what in the very first spot? Audrey?
1.
1. And we've already got the 1, so we're already one step closer. The next thing we want to do is we want to turn right under the 1, this value, class, into a 0. And it's not too hard to turn it into a 0, remember, because we can multiply or change signs or add rows together, as long as we keep one of the rows that we're working with intact. Obviously, which row do we definitely want to leave intact, class? Top row. I mean, can it get easier than 1, 1, 1, 1? No. So I'm going to keep the top row intact, but to create a 0 right here, what might I do, Genesis?
Multiply the top by -1.
Yeah, just change all the signs across the top, or for that matter, since this has negatives in it, I can change all the signs across the middle and then add them together, and my sum will go here in the second spot. So what do I get here?
0, 0, 3, 3.
Now, hold on a second. Do I need both of these numbers to be zeros? No, but in the bottom row I would. Does that make sense? So all of a sudden now, that becomes my bottom row, and for now, I'm going to keep the middle row. But no, I'm not going to keep the middle row intact. I'm going to get that 0 here as well, because this is going to become my middle row. How do I make this number become a 0? Kendall?
Multiply the top by 3.
Well, that wouldn't quite be the 0, but multiply by not 3, but -3. Right, that gives me, of course, -3s everywhere. And then when I add, this gives me what new, again, we're putting it in the middle now. What do we get?
0, -5, -2, and 3.
There we go. And all of a sudden, I've got my 1, 0, 0, my 1 and my triangle is zeros, and I'm ready to solve. And so I plug in the z, I plug in an equal sign, and class, what's z? 1. I plug in the 1, and I write in a y, multiply, class,
-2.
add it to the other side. All right, so if -5y equals 5, what's y, class?
-1.
All right, so we plug in the -1 and the +1. Of course, -1 and +1 are gonna cancel. So I'm just left with x is equal to 1, so x equals 1. And we write them, of course, x, y, z order. What do we end up with for our answer, Michael?
1, -1, 1.
There we go. And how many have this answer? I saw a few of you with this answer. Thought I saw a couple of you with that answer. All right. Like, I don't know if the other person did or not. I can't raise my hand. But Brandon knows that Genesis did, so he's like, all right, questions on this. Now again, this one happened to work. I mean, once I got that double 0, that was a huge time saver, right? It's not always going to work out that nicely, but I thought the homework problem worked out really great. Questions on this? Questions on this? Since most of you didn't get it, questions? All right, let's take a look at a couple more together, and then, like I said, I'm going to give you a chance to work some of these on your own. Number 13, again, don't copy the problem down, copy its matrix down instead. Copy down the matrix for number 3, and tell you what, as you're writing it, tell me what we're writing here, Maddie.
2, -1, 1, 4. 1, -2, 3, 1. 2, 1, -3, 4.
All right. All right, what should we do first as we solve the matrix here? Brandon? There's a couple ways I could do it, but what's probably the easiest way to put a 1 right there?
Switch the middle and the top.
Just switch the middle and top rows so that my top row will become the 1, -2, 3, 1. Now I can do more than just that on this first step, right? I've got the switch, but I also need to, by the way, if this means that this is now row 2, row 1, row 3, these two numbers both have to eventually become class 0. So let's get one of them to be a 0 right now, Genesis.
Multiply the top row by -2. The R1 by -2.
Multiply one of these by a -2?
The R1 by -2.
Oh, multiply this by a negative. We could
Or we can switch this
on
the bottom one.
on row 3, and if I just change the signs here and put my what is now going to be row 2 with row 3, that's going to produce the 0 we're looking for. So what should I write in for my row 2?
0, -2, 4, 0.
All right, and then one of the rows has to stay the same, so maybe, you know what, I'll copy this as my row 3. We'll say that that was row 2 and this is row 3. Again, the nice thing about the matrix, you have that flexibility. It's just whatever you feel like doing as long as it's mathematically sound. Now at this point, to knock out the other, I do have to go and do what he said a moment ago, Audrey.
You have to multiply the top row by -2.
Right, now I'll go ahead and multiply the -2. I'm not going to leave it with the -2 in there. I'm just doing it long enough to knock out this value here. So temporarily, what does my top row become?
-2, +4, -6, -2.
All right, and then we'll add my adjusted row and bottom row. Of course, we're keeping the middle row. We like it. But my bottom row is going to become what now?
0, 3, -5, 2.
There we go. Okay, so we've got the 1, we've got 2 of our zeros. Now we've got to produce another 0. And how might we do that? Kendall?
You can multiply the top by a 3 and the bottom by a 2.
I like the 2 here because that gives me a 6. Now, if I put the 3 through the top, this does give me the -6, but it would also give me a 3, which I don't want to put with a 0. So, but we could do the same thing by putting the 3 through the middle, couldn't we? It would still give a -6, +6. So let's do that. I'm going to keep the top row. I'm actually going to keep the middle row. But I'm going to change my bottom row after I multiply the 3 and the 2. So temporarily, what do my rows become?
0, -6, 12, 0, 6, -2, 4.
All right, so we put those together. My bottom row is going to be what?
0, 0, 2, 4.
All right, and now I've got the 1 with the triangle of zeros under. Questions on this so far? We following, keeping up? Getting to the point, hopefully, where we think, yeah, I'm starting to see these things on my own. I'm starting to think of these again. And again, this is not the only way to approach it, right? It's just a way we're doing. So there's a number of different ways you can approach them. It's just whatever your brain sees as easiest. But we go ahead and plug in the z equals. Obviously, then, Michael, z equals.
2.
And we plug in the 2. That gives us, move it over as a, and we end up with a y equals, well, -2y equals -8, so y would equal 4, and then we can plug in the 4 and the 2, and class, -2 times 4? -8, 3 times 2, 6 and -8,
-2.
kick the -2 out, and we end up with x is equal to 3. And we'll write our answer, how, class?
3, 4, 2.
3, 4, 2. And there we go. Questions on 13. One more together. One more together, and then it's going to be your turn to try it all on your own. Number 14. What should I write down here, Brandon?
1, 1, 3, 6, 1, 0, 4, 5, 1, 1, 1, 4.
All right. All right. Michael, thoughts?
You already have the 1,
Mm-hmm.
so you can put a negative through the middle.
Okay.
And then you can cancel
Which are you adding here? Top 2?
Yeah.
Okay, adding the top two. So I assume we're going to keep the top one, and then what's our new middle going to become?
0, 0. No, 1. -1, 1.
All right, and for now, I'll go and leave this. It only takes a second to recopy it anyway. All right, now what, Kendall?
You can switch the signs in the top one and subtract that from the bottom one.
All right, so again, I assume you want to still leave the top intact, but we'll put the negative through for sake of adding. We'll leave the middle row intact for now as well. Bottom row becomes?
0, 0, -2, -2.
Man, that worked out great, didn't it? We got both zeros in one step. We're completely ready to solve. Someone in your head, what is z?
1.
Positive 1. What is y? And what is x? That was almost real speed. Very little explanation, right? You doing the thought, me writing it down. Man, don't you think that's quicker than the other way? Now that we started to get a hang of it? Now, maybe that one just worked out really nice like the homework did, but I'm thinking this is pretty fast. Questions on this before you try one on your own? All right, now the hard part about going over ones you do on your own is you could all go a number of different directions. So I won't be able to necessarily show everybody's way of doing it. We'll end up showing one of the ways on the board here in a moment, but first, do number 16 at your seats. Number 16 at your seats, there on page 292. So I figured out most of the pattern here. What happened if I call him Abby? Who answers that? Nobody answers.
Genesis' stomach does.
It does what?
It answers.
The camera answers.
No, Genesis is.
Genesis isn't.
Genesis' stomach.
Genesis' stomach answers. This I got it here. All right, Abby, what do we do first? I hear nothing. There, you give her the mirror. There we go. Okay. If you've got the right answer, again, your work may not match mine perfectly, you may have done it differently, but if you're good with 16, go on to 19. Here in a moment, we'll go over number 16 together, we'll take questions. Working these with essentially number puzzles. Kendall, that looked, well, real Kendall, Maddie, that looked like, you're good? All right. I forgot who she was for a minute. How many are good on 16? You got the correct answer. All right. Good. And then Brandon, you were, or Genesis, you were looking for your mistake a moment ago and you found it? All right. For the sake of the video, real quick, let's go over what I did. Anyone do exactly what I did? I think that's probably a long shot. Okay, a few of you actually did. All right, I started by keeping my top row because I liked it, so it never changed. I added these two rows to get the 0, 4, negative 2, 2. And then I also put a 2 through the bottom to get negative 2, 6, negative 4, 8, and then added that to the bottom to get 0, 9, negative 3, 6. Then I saw all I needed was to get a 0 here by knocking these out. And I'm like, I don't want to do a 36. That's just huge. So instead I took a 3 out to get the number smaller. Then the number became a 12. So 4 through the bottom, and then a negative 3 through the top. So I can add them together. And again, I kept my top row, kept my middle row. It was the bottom row that became the sum of all of it and gave me my answers. Questions at all on 16? All right, 19. As many of you have already started, go ahead and keep working on 19. Yes. Okay. That makes me feel better. I get so used to 1s and 2s. If you're good on 19, go on to 22. Entire building is vibrating. How many done with 19? Finished with 19? All right. How many got the correct answer? All right, questions 19. Gonna leave it up a little longer.
Tom doesn't finish it.
Okay, that's okay. Leave it up a little longer. You can start on 22 if you're good to go. On 22 already. Do you think this is faster than the old way of solving systems? All right, let's talk about 19 real quick. Most of you are starting to figure out, man, that top row, you're going to use it a bunch anyway, right? So there's all kinds of little shortcuts you can take on this. Again, when I first showed it, every single step basically got a new matrix. It takes forever. You don't have to do it that way. It's a good way to teach it, but it's a lousy way to work it, right? So I said, well, first of all, if I put a -2 through the top row, and I just wrote it right here, I can cancel some stuff. So I did, kept the top row intact, multiplied the -2, and then added to get this row. Realized, man, that would make a great third row. I'd already written it there, I was too lazy to erase it. All right, so then I said, well, I'm also gonna put a 3 through the top row. And I put it up here, 3, -3, 6, 3, added to get the 0, -2, 8, 2. Then I went and flip-flopped, just as a formality, put this row in the middle, this row at the bottom, Able to solve? How many had that answer on 19 when we got all done? Questions at all on 19? Okay. 22. How many finished with 22? Most of you finished with 22. How many had the correct answer on 22? All right. Question. Okay, so you're still working. Okay, go ahead. Keep working on that. If you're finished, 18 is next. We're developing mastery here, I think, and that's good. The more you do, the faster you get, the better you get. Anyone still working on 22? Still finishing up 22. All right, everyone good to go now on 22? All right, I'll go and erase that. And give people a moment to catch up here on 18. How many are already finished with 18 and got the correct answer? Maddie and Audrey and Genesis, great job. Just waiting on Michael, and Kendall, and Brandon to finish up.
Hurry up, Brandon.
And kind of like a number puzzle, right? It's just kind of figure out what you do, a lot of options available, play with it till you get it. Just another minute or so. Two of them, okay. We're gonna go over this one in a second. All right, let's go ahead and take a look at number 18, just talking through another one here. I liked my top row. I didn't mess with it the rest of the way. I just left it intact. I saw that these two rows already, if I just changed the signs, well, I don't know why I put a negative on the 0, but whatever, I would be able to cancel and get a 0. So I added these together to get 0, these to get -2, these to get 4, and these to get -6. So I made that my second row. Then I put a -2 all the way through the top. I wrote it up here, put that with the bottom row to put the bottom row in place. 0, -5, 9, -16. Then you got to put these two together. It's a 5 and a -2. Multiply them. I went ahead and wrote them down here though, rather than rewriting the whole matrix with them. Left the top row, left the middle row, and took the sum to put in the bottom. The z equals 1 was pretty easy. Ended up getting the y equals 5, and then the x equals 2. Questions on that? Questions there? All right, let's take a look at 21 as we kind of wrap up here. Now, if I were to just take the left-hand side of the equal sign, I could make a matrix just with the numbers 1, 2, -1, and so forth. What kind of matrix would this be if I just took the left-hand side, class?
3x3?
It'd be a 3 by 3, right? But if I just took the left side, I just took the numbers that are multiplied by the letters. What do we call this? It's called the coefficient matrix because you're taking all of the coefficients together. If I made a matrix with just the numbers that are on the right-hand side, the 3, the 0, the 8, yes, it's a column matrix, but what do we call this matrix? The constant matrix, because it's just the constants. But of course, instead of writing them as two separate matrices, we put it together, don't we? And just put a little line separating the two parts and refer to this collectively, class, as an augmented matrix. So Brandon's got the terms down well. All right, so let's try this one more time, class. I mean, Genesis has this down well, my bad. So bad with names. All right, so this side is the coefficient matrix. This side is the
Constant.
I'm going to put it all together and make an augmented matrix. It's way too lazy to write them as two separate matrices in the first place. All right, let's solve this one together for a change. And that'll kind of be how we'll wrap up the hour. Of course, you'll have more for homework. You'll get a chance to practice on your own and do as quickly as you want. But let's start with Michael, and we'll work our way around the room.
Multiply -2 across the top.
Okay, to get what?
-2, -4, 2, and -6.
All right, and we'll put that with the
The middle.
middle. All right, and I assume to make a new middle, correct?
Yes.
So we want to leave the top alone, but our middle's going to become what now, Michael?
0, -3, 0, -6.
All right, and then what might we do? Brandon? Well, we could keep the bottom, or we could actually do the same thing, right? We multiply a -2 through the top and add it to here. We could also add the -2 down here. That would also give us a 0, wouldn't it? Let's do that also.
0, -9, 5.
There we go. All right, now what, Maddie?
3 in the middle
Okay.
to get 0, negative 9, 0, negative 18.
But is that going to cancel with my bottom row?
You can change this one
Where?
in the bottom.
All right. So again, we're going to keep the 1, 2, negative 1, 3. We're going to keep the 0, negative 3, 0, 6, but the bottom becomes
0, 0, 5, and 20.
all right. And Audrey, what do we get for our z?
4.
And notice there's nowhere to plug the 4 in. So literally, this is now just 3y equals 6. Y is really easy, Kendall. Well, negative 2, right? And then we do have to plug in a couple numbers here. We've got to take the time to plug in the 4 and the negative 2 and multiply them and combine them and move it all over. And we end up getting what for our x here on number 21?
Is it a negative 6?
Is that a negative 6? That's a great question. It is a negative 6. Let's try a 2. And let's try a positive 2. There we go again with the negatives. All right. And so what are they getting for x here, Genesis? 3. And there's our answer, 3, 2, 4. By the way, do you see that it would be really easy to solve a matrix if I had, for instance, something like this? Because when you get your z, you don't even have to plug it in. And when you get your y and your z, there's nowhere to plug them in. This is another form of matrix solving where you do the triangle of zeros in the top corner and the bottom corner. That way x is 7. Well, actually, the real method, you end up with 1s in all the spots because you would divide the 2 out, divide the 4 out. But you end up with your x, y, and z as just the coefficients on the one side. That takes more work, so I'm not teaching that method to you, but in college, you take a college algebra class, they'll probably teach you that method of elimination as well. For our purposes, I feel like this is the easier method, the less number work method, so I like this method. But if you don't like plugging stuff in later, the other method works great too. Questions on this? All right, your homework for this evening. Homework for this evening is to do page 315 to 316, pages 315 to 316, numbers 1 through 11, and 14 to 18, numbers 1 through 11, 14 through 18, and 23. 1 through 11, 14 through 18, and 23. Take a look at all of this in our next lesson, and a few minutes actually to get a head start on this, and then we'll take a look at this in our next lesson. Have a wonderful rest of your April Fool's Day.